Hello, everyone. It's 1 p.m. Eastern, and that means it's time to begin our special CoCoRaHS Weather Talk webinar on the significant weather events of 2024. A very warm welcome to all of you with us today. I'm your host, meteorologist Henry Regis. Running the technical side of our program is Noah Newman. We're coming to you live from Fort Collins, Colorado. For those of you who are unable to join us for our live broadcast, we are recording today's talk, and it will be available later this week on our website. All of our Weather Talk webinars are sponsored by the generous donations from listeners and CoCoRaHS observers. Well, we're excited to have back with us, as we do each January, our good friend Greg Carbin. And Greg is now retired up in Vermont. He might be tapping maple trees here in a month or so. In a previous life, Greg was the chief of forecast operations for NOAA's Weather Prediction Center in College Park, Maryland, and he held several other jobs with NOAA before that. Each year, Greg puts together a presentation on the top 10 weather events in the United States during the previous year. Well, Greg, it's so great to have you back with us again this year. And how's retirement going? How is things going up there in Vermont?
It's going very well, Henry, and thanks for having me here. Let me see if I can get my screen in order. I'm going to try to share here. Let's see. Hopefully you can see the screen.
We can.
Very good.
There's something. Noah, do you know there's something on the screen there? Oh, there we go. We got you.
All
Oh,
right.
I love the plaid. That's great.
It's going very well. It's a snowy day here in central Vermont. I was just thinking, I think we've had basically 7 days in a row with some light snow falling. A little colder than I'd like it to be, but it is January after all, and we're hanging in there with pretty chilly temps the last week or so. So it's difficult not to get cabin fever. Welcome to my cabin. It is a small house. That's why I'm kind of like halfway in the kitchen here. Not a lot of room, but it's cozy and it's easy to keep warm. And it's in a beautiful spot in central Vermont in the Green Mountains. And yeah, there may be some maple trees to tap here in a couple of months. The season has been getting earlier up here every year. Some of the major maple syrup producers start now, even in February. It used to be about March or April. And I'll have a little bit more about growing up here and the connection to the place at the end of the talk today. So without further ado, we can get along here.
Thanks,
So
Greg.
this is, yep. All set?
All set. Go ahead.
Okay. So again, it's time for a review of meteorological memories of the past year. And for those of you joining for the first time, I've been doing this over 20 years. And these are my memories. They may not coincide with some of the more memorable events you've experienced during the year. They're not really ranked in any particular order. We will talk about some of the impacts from some of these significant events, which probably wouldn't surprise most of you who are in touch with the weather. But there may be some other events that are kind of smaller scale. Vermont makes a big appearance in this year's talk. I'll just tell you that ahead of time. And they're not, they're going to present them generally in chronological order. Being retired, I didn't really feel the pressure this year that I might have in other years. But hopefully, you'll enjoy it nonetheless. So let's get underway. Memory number one actually dates back to just about a year ago when we had back-to-back coast-to-coast cyclones that were pretty impressive. I remember this event primarily. I was working at the Weather Prediction Center in College Park, Maryland, and I remember looking at the image on the left here, and then looking at the medium range forecast for a few days later and seeing the image on the right and being a bit confused because they looked almost identical. And sure enough, it was an almost identical system that moved from the West Coast to the East Coast and brought a lot of snow, a lot of winter weather, severe weather in the Mid-South and Southeast United States, and then also some pretty amazing and significant coastal flooding to parts of the Northeast, especially the coast of Maine. I'm going to try this here. I'm going to click this link so that we can look at a satellite review of this event. And I don't know whether you can see that. I hopefully you can see this on your screen.
Looks good. Yeah, it's great.
Okay, good. So you can see the deep cyclone coming in across the southwest United States and then wrapping up rapidly across the southern plains and then up into the Great Lakes and onto the East Coast. And then another one right on its tail coming across the west and looking very similar, what we call a baroclinic leaf structure here, deep low developing, probably some blowing dust and severe weather in the warm sector of this. And we'll run it one more time here. But these coast-to-coast cyclones were quite memorable last year and very vigorous systems that set up around this time of year, a year ago, around the middle of January. And there's a theme, I think, that shows up a couple times in this talk. And I didn't realize it until after I had finished the other events that this kind of repeat activity. And we know that the atmosphere does repeat itself. But there are these repeat events as well, never really identical in nature, but they can be very close. So this is what you need in the upper levels of the atmosphere is the deep trough, and that's in the upper left here, just showing the week-long upper level pressure anomaly across the United States or the lower 48 states and southern Canada. And anomalously low pressure in the atmosphere from basically the Canadian Rockies to the Midwest. And then these systems basically feed off of that trough. They move in from the West Coast, amplify across the Southwest and Southern Plains, and then move off to the east. In the upper right is a view of the accumulated snowfall from these events. And the dark blue starts at about a foot of snow. So you can see pretty widespread areas of the U.S. Receiving at least a foot of snow, especially across the Rockies, as we would expect, and then from the plains to the Great Lakes and into parts of New England, and even into parts of the Mid-South there from northern Arkansas across Kentucky and Tennessee. So very prolific snowfall producers and also widespread severe weather, especially with the lead system when there was a moisture and instability to tap ahead of that lead disturbance, widespread damaging wind reports and also some tornadoes. So this gives you basically the large scale look of the system and then its related impacts. Businesses and political campaigns were affected or canceled. This is during the primary season or the campaign season. Heavy snow disrupted local economies, led to significant cleanup costs. The postponement of the NFL playoff game in Buffalo occurred during these events. And the overall losses estimated by the National Centers for Environmental Information is about $6 billion. And taking a look here in the lower right of the image are some screenshots I took of the storm flooding, the coastal flooding along the coast of Maine. These are down around southwest Maine, but showing the high surf during the storm and then compared to what you might see on a normal day. If you look at some of the records here, the January 10th crest, and I really concentrate here on Bar Harbor and Cutler, which are a little bit further up the coast of Maine. Bar Harbor has a record going back to 1947, Eastport, Maine, back to 1929. And these were incredibly high tides, probably related to a lunar cycle, as well as the storm surge, as well as a very small but constant rise in sea level due to climate change. And so we're seeing with these particular storms how they ranked with respect to prior coastal flood events. So there was a lot of damage on the coast of Maine due to these systems. Memory number 2, go to March Madness with tornadoes and severe storms in the heartland. And here's kind of a loop of the upper level winds associated with this system and kind of atypical, perhaps. I mean, not really a strong identified trough in the atmosphere that produced this widespread severe weather, more like an impulse that emanated from a deepening trough in the southwest U.S. and then spread out across the Midwest in concert with a rapid return of moisture. On the right here is a loop of the precipitable water, and you can see the moisture feeding north from the Gulf of Mexico into this zone of increasing wind speeds in the mid-levels. And that's really two of the primary ingredients, and then lift associated with the shortwave trough. These ingredients contributing to a widespread severe weather outbreak. Hundreds of hail, tornado, and severe wind reports were noted across the Midwest. on March 13th through the 14th, along an axis from southern Missouri to central Ohio. And large hail measured 3 to 4 inches in diameter and was reported in the St. Louis area. And there were 3 fatalities and 27 injuries with an EF3 tornado that traversed Ohio's southwest Ohio, western Ohio counties there during the event. Kind of unusually far north for mid-March, not unprecedented, but a bit farther north than you might expect severe weather at this time of year. The 2 people were injured in an EF2 tornado that touched down in Jefferson County, Indiana, and another 38 injuries were reported with an EF3 tornado in Selma, Indiana. At least 17 tornadoes were confirmed in the Midwest during this outbreak. So a very memorable mid-March outbreak of severe weather. Some pictures from this event showing the golf ball hail, the damage from the tornado in Ohio, and the supercell there in the lower right is basically the beginning of the event. I think that is taken from Kansas, and really wrapped up supercell on radar and the velocity couplet associated with that, probably tornado with this system, as well as very large hail. Memory 3, moving right along here. This one's really special to me, the Great North American Eclipse. I did make it into New England to see this. This is probably, I would say, my last hurrah as an official meteorologist with the National Weather Service, and never anticipated that it would go out this way. You know, spent many years forecasting severe storms and then extreme rainfall events. And to have the last event be related to cloud cover, well, it sounds kind of boring. It was pretty exciting week overall. So there's a picture of the eclipse in totality there on the left, and then the track of the eclipse shadow across the Earth during April 8th of the past year. And what's interesting about this is there were a lot of people in the path of the eclipse. So these are the cities within the daytime path of totality, and the estimated population around 30 million or so. And given that path, the time of year, the relative rarity, I mean, we're 20 years away from another one over the contiguous United States, and over 30 million people along the path within, under 8 hours of driving. The cloud cover forecast for late morning to afternoon on April 8th became increasingly interesting to millions of people, including myself. And the Weather Service Weather Prediction Center sort of became the national center of expertise with respect to this event, issuing specialized key messages in the week leading up to the eclipse. So all eyes were on what the forecast was for the skies for this event. And we developed these key messages. This was the first one issued about a week out on April 1st. And we went back and forth in operations trying to determine what's the best way to message the forecast, knowing, there's going to be uncertainty with respect to cloud cover. We did decide to use the percent of sky covered by clouds here from the national blend of models. And I did a little bit of quick research before we decided to go this way, and I took a look at the verification of this particular cloud product with respect to other events in the week leading up to the end of March, and it looked like it did a pretty decent job. Of course, there's a lot of variability in forecast accuracy at different time ranges and in different weather regimes, but it looked like this might be reasonable to start to message about a week out, given the technology and the imagery that we had available. So the grayscale here showing, and then I came up with the path of the different versions of the eclipse with totality across basically from the Rio Grande to the Northeast. And then each day we would refine this and update it and have it sent out around early afternoon, and trying to, emphasize, check back, things can change. But the general idea here was that, where a lot of people were headed, South Texas, where it was nice early spring weather, you might run into some problems with cloud cover there. Maybe a better shot in the Midwest, apart from the Missouri boot heel, maybe up the Ohio Valley. Then again, not so great in the eastern Great Lakes. And then at all of the locations, northern New England might be one of the best spots as far as staying away from cloud cover. So how did this do? Well, we'll take a look here at a little loop I put together, just showing not quite aligned as far as the maps go, very close, but this is the day 6 forecast and then the day of the event. And overall, you see a little bit better refinement in the probability values, and that's related to the ensemble forecast and the spread in the ensemble. So as you get closer to the event, there's likely to be less spread and more confidence in the forecast. But overall, the cloud cover across South Texas did persist right up to the day of. I know there were some breaks there, and some folks got lucky breaks if they went that far south. The forecast improved pretty nicely from Little Rock to Paducah up through Indianapolis. The Great Lakes, they continue to have a challenge, as was originally forecast, basically Cleveland, Buffalo, parts of New York. Not ideal viewing conditions for the early afternoon or afternoon eclipse. And then northern New England stayed in the clear. However, up there, it really only lasted less than 2 minutes as far as totality goes, and you had a little bit more of a duration the farther southwest on the path you went. I happened to be in northern New Hampshire, and it was really quite remarkable. I'd heard people say before, if you ever have a chance of seeing a total eclipse of the sun, you will not forget it, and you will want to see another, and that is absolutely the truth. I can't wait until I get an opportunity to see one again. But it was really neat. I really enjoyed putting these forecasts together, working with the staff at WPC and getting the message out as far as where your best shot would be to have good viewing for the eclipse. So that's a good memory for 2024. Okay, I've combined memories 4 and 5, and you want to bear with me here a little bit because we're gonna get really into the meteorology of a very active springtime severe weather regime. It's been a while since I've worked in severe weather, but I was at SPC for 20 years. And so I was kind of interested in doing a review of how active the pattern was during the typical springtime activity. So this is a calendar essentially showing the highest categorical risk in the Storm Prediction Center outlooks for the months of April and May. And this is just one way to evaluate the level of severe weather activity or potential forecast severe is to look into the number of SPC moderate to high risk issuances in the day 1 outlook. So over the past 10 years, April and May, the April and May of this past year, 2024, had the most enhanced or greater risk days than any April period. Back to 2015, I think, is when we started doing the enhanced risk. And that was 37. And that's more than 10 days greater than the average. So this was a really, really busy time for forecasters at the Storm Prediction Center and also in the field as far as the severe weather warnings go. And this is great information that can be generated from the Iowa Mesonet. I want to thank Daryl Hertzman for all the fine work he's done there to allow this type of analysis using the tools that he has available on the web. Another tool that I use to assess the active regime for just looking at moderate risk outlooks on day 1. 9 of the 11 issued. I think there might be 12 now for the year. When I put the talk together, there were 11. 9 of the 11 issued for the year were contained within April and May. 4 moderate days in April and 5 in May, and 1 high risk, mostly covering Oklahoma on Monday, May 6, 2024. So you see, that's not necessarily uncommon, but it is kind of compressed. You see that after May there aren't any other risks. Well, there was actually one, I guess, in July, and then more recently, I think we had one toward the end of the year. But at the time when I did this graphic, it was kind of notable how compressed this period of very active severe weather was. And it takes quite a bit of confidence and also the potential for high-end severe weather for the Storm Prediction Center to put your area in a moderate risk. Looking at the actual tornadoes, tornado reports, as you might expect, trended up considerably during these 2 months of April and May. the number of events in fatalities and also widespread monetary losses due to these events, and started to trend up to around the 90th percentile. I think since then, if the question comes in, what's happened since, I think we've trended more toward the normal. So again, this period from April, May, it can be busy, and it usually is quite active with respect to severe weather. But 2024 certainly stood out in terms of some pretty high-end events. And let's take a look at a couple of those. And the reason I combined memories here is because not only looking at the overall statistics for this period of time, but let's look at a couple of significant episodes of severe weather.
Greg, let me ask you real quick.
Yeah.
Was there a
Yep.
reason why this was a more active? Was there anything that contributed to that normally we wouldn't see?
So, I mean, basically, the regime you're in is an active jet with plenty of warmth and moisture to fuel thunderstorm activity. So, just when we look at the ingredients for severe weather, moisture, instability, lift, and shear, you can often get two of the three in combination, but to get three of the three consistently time and again is a little bit difficult for the atmosphere to do. But we noticed in past events that once you have a pretty large outbreak, you can go long periods of time without another one because you've kind of cleaned up the atmosphere from that pent up instability and the pattern changes after a large outbreak. In this particular case, it didn't seem like there was a great pattern change. You just had repeat storm systems tapping into moisture, instability, lift, and shear. So it's the persistence of those ingredients that brings about these regimes. And they're not always tornado events, right? So here you're looking, this is May 16th. I'm sure there were tornadoes embedded within this, but this is an especially strong and long-lasting derecho that charged across central Texas. It struck Houston. Again, going back, Houston will appear again in this talk, similar to the repeat activity I talked about earlier. This storm unleashed tornadoes and destructive winds that reached 100 miles an hour, and it shattered windows, tore roofs off homes, and toppled trees and power lines. Nearly 1 million homes and businesses in the greater Houston area lost power, according to reports. And this system persisted all the way into the western coast of Florida. So this is the one that stood out. Houston here, really neat imagery showing basically the lights, the electrical grid across Houston from satellite. And you can really see where that core of high winds went just to the north of central Houston, just to the north of the center of town there, and really took out a lot of trees and power lines across that part of Houston. And then wind damage, picture of downtown high rise there from the National Weather Service. And power outages were widespread and noticeable in this nighttime imagery. And unfortunately, it means AC goes out, and it was really ugly in the wake of the event. Very warm conditions down there, and it took quite a while to restore power in some spots. In many areas, that was around. This was May 16th. The power maybe 3-4 days in some places. Roughly 50,000 customers in Harris County were still waiting for power to be restored over a week later. So not a great way to go into the middle of May. And then toward the end of May, an incredibly active period, again, for severe weather across a broad swath of the central United States. An outbreak producing more than 110 tornadoes developed across many central states. And the states most affected included Missouri, Arkansas, Texas, Oklahoma, Illinois, and Kentucky. Widespread damage to homes and businesses, vehicles, and agriculture and other infrastructure in these areas. On May 25th, an EF3 tornado tracked through Montague, Cook, and Denton counties of Texas with maximum winds of 140 miles an hour, caused 7 fatalities and at least 100 injuries. So for memories 4 and 5, just a really busy and dangerous period of severe weather, mostly across the middle of the country. So now we get into the tropics, and the early season forecasts were ominous, and boy, did it look like that was going to come to pass. When on In July of all months, we're already seeing Hurricane Beryl, the earliest recorded Category 5 hurricane in the Atlantic Basin. And it made multiple landfalls during its track in early July 2024. Notably, it struck Carriacou Island in Grenada on July 1st as a Category 4 storm with 150-mile-an-hour winds. It later made landfall near Matagorda, Texas on July 8th as a Category 1. Beryl became a hurricane just at 49.3 degrees west, the farthest east an Atlantic hurricane had formed in the tropics, which the tropics considered north of 23.5 degrees north. If measured straight east from the southern tip of Florida, almost 2,000 miles out in the Atlantic. And the old record was the Cuba-Brownsville hurricane of 1933, which formed at 59 degrees west longitude. So again, landfall number 3 for Beryl was Matagorda, Texas, as a Category 1 on July 8th. It was the earliest hurricane to make landfall in Texas since Bonnie, which made landfall on June 26th in 1986. And Beryl was the 10th hurricane to make landfall in Texas in July, and the first since Hannah in 2020. And there you see the most intense period of the storm's life there, landfall on the Texas coast and the overall track of Hurricane Beryl in July. So the impacts, Houston gets hit again. So repeat storm for Houston. The eye wall essentially moved across the Houston metro area a little over a month and a half since the May derecho, and a relatively widespread outbreak of tornadoes in the eastern semicircle of the circulation, at least 60 tornadoes, record tornado warning operations for any day on record for Shreveport. I just realized that'll be another theme that appears again at another location with another hurricane this season. The system continued to spawn heavy rain and damaging tornadoes well inland, with a tornado producing EF3 damage at Mount Vernon, Indiana on July 9th. So total U.S. fatalities are estimated at around 50 and property losses in excess of $7 billion. So you see the tornado watch that was issued and then the tornado warning polygons as Beryl circulation moved up across Texas and Louisiana. On to memory. Oh, we're still on Beryl. Sorry, a couple of plots that I made to remember Beryl by. So the hurricane force winds on the left here. This is really the gust product from the real-time mesoscale analysis. It's not direct observations. These are gridded data, but you can kind of see where the eye wall came on shore here. You've got 100 plus mile per hour wind gusts, and then tracked inland. This is Houston. So 80, easily 75, 80 mile an hour winds moving across the Houston area as Beryl moved inland. And then the rainfall swath associated with Beryl from July 8th through the 10th. The red here is 3 inches of rain in this period of time. Of course, there's localized reports of over 10 inches down here in Texas with landfall. And I'll bring your attention to where this swath ends, because that will be our memory number 7 coming up here in Vermont. While not a tropical system at this time, this swath of heavy rain contributed to our memory number 7. So a year to the day, in 2023, July 11th, Vermont had a significant, non-tropical extreme rainfall event that resulted in widespread and devastating flooding. And here we come a year to the day, and this is a loop showing Beryl coming ashore here and then tracking and kind of losing identity as a tropical system, but bringing its moisture with it up into the Northeast. And the Vermonters going, what the flood? What the flood is going on here? And how in the world is this even possible? We're just getting recovered after a year of flooding earlier, and here we go again. It was a little more focused this time, but no less devastating for those areas that saw the rainfall. So you see here Beryl circulation back over the Great Lakes. And it's pretty simple when it comes to flooding rain, is where does it rain the heaviest for the longest period of time? And if you kind of eyeball to try to answer that question based on this radar loop, you might come to the conclusion that northern Vermont is where it rains the heaviest for the longest period of time during this loop. I'll let it run one more time. And really, it was an overnight event, which is never good because people go to bed and it's not really raining, and then it starts to pick up overnight. And by morning, the potential for widespread, dangerous flash flooding is ongoing. And so that's how that evolved. Comparing it to the year earlier, these two rainfall plots show you that, maybe 2023 was a much more significant heavy rainfall event across a large part of central northern Vermont this past year. And a couple days, really, most of this rainfall fell in about a 6 to 12 hour period of time, and was situated from northwest or north central Vermont across northeast Vermont. This part of Vermont's called the Northeast Kingdom, and they were hit very, very hard, 6 to 8 inches of rain in about as many hours. About 6 inches of rain in 9 hours across these areas. And it had severe impacts. The towns around Montpelier, St. Johnsbury, the black dots on the map on the right coincide with the towns of Plainfield and Barnett, Vermont. And the pictures that are coming up in the next slide will be from those locations. The rainfall return rate for these areas was between a 200 and 500 year return frequency, probably less than 0.5% chance of happening in any year, yet it happened 2 years in a row. So that's very disturbing, and so are these pictures. One from Barnett, one from Plainfield and Barnett. And I happen to, Vermont's a small state, so you run into people all the time that might be impacted by something like this. And I happen to run into someone who lost just about everything about a week after the event. And so the National Weather Service in Burlington, if you're interested in more information, they've done a really nice write-up of this on their website. And in that write-up, I quote here, by the morning of July 11th, again, a year to the day from the last flood, Vermont Emergency Management had received nearly 700 reports of damage related to the flooding, with numerous roads and bridges impacted, swift water rescues. The secondary impact was there was some scattered supercell storms and severe weather, which is always a little unusual up here, but they do get it. In conclusion, the weather events of July 10th and 11th will go down as one of the most impactful in our region in 2024, while also coincidentally marking the 1 year anniversary of the Great Flood of 2023. So it was kind of hard to not have this in as a memory number 7. A couple other pictures here. I read a compelling story of a young woman who was here on a traveling dental hygienist. So she wasn't from Vermont, but she was living in the Northeast Kingdom of Vermont. This event was not very well forecast. So she goes to bed, no sign of any impending danger. She wakes up in a tiny house up there somewhere in the Northeast Kingdom, surrounded by raging floodwaters. And she stepped off her porch, was swept away. Luckily, she was able to get help and was able to get out of that. But that just gives you some idea of, one, the challenges of forecasting small-scale extreme rainfall events of this magnitude, and also, how do you prepare for something like that? It's a really, really difficult question. Vermont is struggling with this. Vermont is struggling with the climate change. Maybe a few years ago, it looked like it might be a refuge from climate change, but given these events in just the last few years, no place is safe, really. So on to memory 8, arguably the most substantial event in terms of loss of life and monetary damage and just the extreme nature of 2024, Hurricane Helene. On this graphic here, showing you the 5 tropical cyclones to affect the Gulf Coast in 2024. Just give you some idea that the graphic here is really a depiction of the wind field just above the surface and then the moisture being transported by those winds. So give you some idea of the size and extent of the tropical cyclone. And we talked about Beryl. We didn't talk about Debbie or Francine, but you can get some idea here of how big Helene was compared to some of these other earlier storms of the season, probably about twice the size. And we'll have to talk about Milton too, because it was another significant event. But focusing on Helene on September 26th, a Category 4 hurricane with 140-mile-an-hour sustained winds, the strongest hurricane on record to strike the Big Bend region of Florida, having made landfall near Perry, Florida on September 26th. Helene was a massive storm and the third hurricane to hit the Big Bend region in just over a year. So it caused up to 15 feet of storm surge along the Big Bend coast and 6 feet of surge as far south as St. Petersburg. It also caused billions of dollars in damage to Georgia's agricultural sector and then moved inland. And I think we all know what came after that. Looking at some of the max rainfall totals, Helene was at the very top there, unfortunately, over North Carolina. And there's a lot of question, and we'll go into, well, why in North Carolina, not on the Gulf Coast? So we'll start with this synced loop here of the upper levels of the atmosphere, along with the surface and the infrared imagery showing Helene's track up into the eastern Gulf of Mexico, landfall in the Big Bend, and then unfortunately moving north into the southern Appalachians and kind of being trapped by an upper level mid-latitude cyclone that had come across the mid-Mississippi Valley. And so you can kind of see this dance of the atmosphere occur as the tropical system basically gets trapped and then orbits around the larger low pressure system that is sort of lumbering slowly eastward. And so it's partly responsible for keeping the intensity of the tropical surge of moisture focused on the southern Appalachians, perhaps a little longer than it might otherwise be. Had this upper low not been in place, it's not to say that it wouldn't be a devastating event, but this upper low definitely played a role in keeping conditions very extreme in terms of rainfall, perhaps a little while longer. And again, where does it rain the longest, the hardest is where you're going to have the bigger problems occur. This is a really neat graphic from the Center for Hazards Weather Extremes out in California called CW3E. I asked the author of the schematic, Jay Corderia, if I could use it in the talk, and he agreed. Basically just showing the upper low there in purple, kind of a precursor condition too, with the frontal system associated with that upper low, bringing rainfall ahead of the actual tropical cyclone rainfall. But this is just a setup, a schematic showing how the atmosphere was configured in such a way to support the amount of rainfall that we saw over the terrain in North Carolina and parts of eastern Tennessee. And it's led up to 1, 2, and 3 day rainfall amounts in the 1 to 3 foot range, over 30 inches reported around Mount Mitchell. The resulting catastrophic devastation is truly beyond historical comparison. The event sets a new and scary extreme for high-end precip over complex terrain. And the hurricane is the third deadliest hurricane of the modern era, behind Maria and Katrina, with a death toll of over 200. And it's according to National Centers for Environmental Information, which unfortunately is based in Asheville, and they had their own significant impacts occur there at that center. Early estimates suggest the economic losses of Helene could surpass 50 billion, putting the storm costs on the same scale as Katrina, Sandy, and Harvey. So this is just on the left, basically looking at the 3 day recurrence interval, around 1,000-year recurrence interval there across the western North Carolina. And then the actual rainfall that did occur in this 3 day, an estimate here, excess of 20 inches in the yellow. And in addition to the flash flooding, just the incredible record river flooding that occurred. This is the French Broad at Fletcher, showing the past record was just over 20 feet. The new record is over 30 feet. So anytime you break a river flood record by 10 feet, that that's just in new territory. And we saw the devastation that occurred, just incredible devastation across that part of Western North Carolina, and still a lot of recovery, many, many years in some areas. Some areas may never recover from a flood of this magnitude. Just a couple of images here looking down on US 74 from I-40, before and after picture there on the left. Railroad tracks flooded out on the river there, I-40 washed out across the mountains, and just utter devastation due to this amount of rain in this part of the country. So this is enough, right? Unfortunately, we have to talk about Milton. So Hurricane Milton made landfall in Siesta Key, Florida, in Sarasota County on the evening of October 9th. Some parts of the Florida coast had not fully recovered from Helene's wrath. Milton became the 9th hurricane and the second Category 5 hurricane after Beryl the 2024 Atlantic hurricane season. It was one of the most intense hurricanes on record in the Atlantic basin overall. Remember, reaching Category 5 strength in the Gulf of Mexico. And this is a Tampa Bay worst case scenario. And those scenarios were in play early in Milton's forecast. However, to the credit of the National Hurricane Center, the exceptional forecasts out of NHC consistently keeping landfall just to the south of the mouth of Tampa Bay. And they were right, as a testament to the intense large-scale wind and mass adjustments associated with Milton. A pre-landfall tropical tornado outbreak was fostered and that's over 300 miles away from the center. So even when you think you got the forecast nailed down, there are these, flies in the ointment, so to speak, that can come about when you have these dramatic changes occurring in the mass fields of the atmosphere in the presence of deep tropical moisture. And so, well removed from the actual center, and more deadly perhaps than the actual center ended up being, was the tornado outbreak that occurred across southern and central parts of Florida, even along the east coast of Florida. But first, let's look at the pressure. So ranks number 5 in the Atlantic basin as for its bottoming out there in the Gulf of Mexico before landfall. Milton reached 897 millibars in pressure from recon measurements in the Gulf, and that's the third lowest pressure in the Gulf since 1979 and the 5th lowest in the Atlantic basin on record. And you can see the recon aircraft trace here of the surface pressure in red bottoming out as they go through the eye wall, and the flight level wind speeds dramatically increasing over 160 knots. So pretty ominous to be watching this occur over the Gulf as the system takes a beeline toward Tampa Bay, right? And then the tornadoes. The outbreak places it second when measured by tornado warnings issued in a given day for the state of Florida. So these are basically the number of tornado warnings issued by state for any date. And in Florida, the April 27th outbreak of 2011 in Alabama, that was the most ever in any state on any day. And the second most in any state on any day in terms of warnings was associated with Hurricane Milton. And say the numbers 1 and 3 are warning days from the super outbreak. Number 5 is the catastrophic Hurricane Rita. And in fact, the 55 warnings that the Miami office issued on this day is the most ever put out in one day by that office. So I think we've got 2 National Weather Service offices reach tornado warning records in 2024. If I read this right, one would be Shreveport, with Hurricane Beryl, and then Miami with Hurricane Milton. And then looking at the comparison of Helene, so another significant catastrophic coastal surge event for Florida's Gulf Coast, only 2 weeks removed from Helene's onslaught. But as most of us who watch these events unfold know, each storm presents significant challenges and variability when it comes to storm surge impacts. And there was overlap between these 2 events. And unfortunately, that overlap targeted the 3rd most populated area of the state. At Fort Myers, the gauge rose to 5.26 feet only slightly above the crest that was reached with Helene, but short of the 50-year record set by Hurricane Ian in September of 2022. So just 2 weeks apart, and you're setting major coastal flooding records at Fort Myers and along the southwest and west coast and Big Bend of Florida. We're still on Milton. Let's talk about the rainfall. One of Hurricane Milton's largest and most consequential impacts will be the flooding. A swath of 10 or more inches of rain in 24 hours stretched from the Gulf to the Atlantic coast. At St. Petersburg, almost 19 inches of rain fell during Milton. In just 1 hour, the rain gauge recorded just over 5 inches, an extremely rare rainfall event. And Milton moved across Florida. There were several locations. You can see this is observations here of rainfall. Not sure if the CoCoRaHS got into this. I looked at the CoCoRaHS, and they're very similar rainfall amounts across Florida, but many locations exceeding a foot of rain in 24 hours. And I kind of used a 10-inch isohyet in 24-hour rainfall. It's shown here in the dark black line and the yellow, at least 10 inches of rain in 24 hours. Kind of used that as a measure for what I call prolific daily tropical rainfall events, just to get some sort of idea of how, where does this system rank with respect to other very wet systems. And it's a crude measure, but and it's just set in the 24-hour period from about 7 a.m. to 7 a.m. Eastern time. But I've been doing this in the digital record that goes back to 2005. And this will show you where Milton ranks in the top 10 prolific tropical cyclone rainfall days since 2005. It ranks number 8. I think we didn't have an event in 2023, but if you go back, Ian in 2022 is number 3 up. Number 3 up here in the upper right. You may ask, well, where's Helene in this? Well, Helene's rainfall was over a period of several days. This is just looking at a snapshot of one 24-hour period, and Helene didn't quite meet that in the 24-hour window. So this is kind of has its limits as far as extreme rainfall goes, but it's one way to measure prolific rainfall from tropical cyclones. So that's memory 9. I'm going to go back to Vermont now for memory number 10. So I moved to Vermont in June of 2024, and no regrets. And this is sort of a calendar of pictures that I snapped over the last year to remember the state. So starting in June here in the left, there's June, July, August, September, October. And then the snows came in November. That was kind of fun. We had a Thanksgiving snowstorm with over a foot of snow. And that almost all disappeared just before the new year. And now we're getting some of it back. But I think our highest snow cover was just at the beginning of December around here. And we lost a lot of the snow that we had early in the year, early in the winter. So I grew up here about a quarter mile from where I live now. My interest in meteorology actually started here. Maybe these pictures are a testament to that. It's a beautiful place to live. Where I live at about 1,600 feet elevation, I have a beautiful view off to the east-northeast. And when I was growing up here, I became interested in meteorology primarily because of the winter weather, the winter storms, because we're very well situated for picking up heavy snow, like you see in the lower right there, from nor'easters, from coastal storms, because the way the winds are configured, we get into an upslope flow regime here, and the snowfall is very impressive. As a kid, the most impressive was about 6 feet on the ground at any one time. I think that was the 78, 79 season. And I still have some log books from when I was a teenager growing up here, keeping track of the max min temperature and precipitation. And they kind of, the log books drop off as you get into spring and summer because it's all about winter up here. And if you can live through the winter up here, there's a lot of rewards at other times of the year, as you see from these pictures. Just absolutely beautiful weather. This past summer, while warmer than normal, was very comfortable since I've spent time in much warmer climates than this. We had quite a remarkable summer and fall up here. And so that's my memory number 10. We could argue there are other memories I should be talking about. Very unusual heat, especially in the Southwest U.S. I meant to look into that a little bit more, but I just didn't get to it. So I hope you've enjoyed the talk today, and I appreciate again CoCoRaHS having me speak about my annual meteorological memories. Thanks a lot. And I'll answer any questions if we have time.
Yeah, just great stuff, Greg. We appreciate each year, and boy, what beautiful pictures there. It's a great collage there of Vermont. I've got a quick question for you of the tornado outbreak with Hurricane Milton along the Florida, southern Florida, and eastern Florida. Um, how unusual is that to get them supercells like that? Could it have been from the storm moving in from the west to east? Um,
Yeah, the angle of the approach to the coast um, certainly plays some role in the wind, shear and the character of the wind profile above the surface. I think the time of day also plays a role. Another meteorological memory I have related to tropical cyclones approaching Florida was an unfortunate early morning event similar to this. Actually, I remember working at SPC, and I really need to. I can't remember now. I can't remember the name of the tropical system. I should know that. And then I could go back and look at this in a little more detail. I was working the lead desk on the midnight shift, leading up to a tropical system. I don't think it was a very intense one, but it had a well-defined wind field that was increasing. And I thought I could get away with, letting the next shift decide on where they wanted to do the watch. But boy, it came up very quickly. The wind fields that were associated with the circulation moved across South Florida. And of course, the access that area has to rich tropical moisture resulted in tornadoes beginning very early in the day. And again, not necessarily typical with our conceptual model. You think you'd want a little bit of surface heating to get things going. And I was caught a bit by surprise. I think I did get the watch out, or it was right at shift change. It was very close, and I felt like, boy, I really dropped the ball there. I could have probably had a little more lead time on this. So these systems can sneak up as far as the wind field goes, and as far as mass adjustment goes, associated with the deep low pressure with the hurricane. And so I'd been exposed to this before. And there could also be some relationship of how the friction changes from ocean to land in order to support the development of supercell thunderstorms like this. And some of these were really long track. So there's something about South Florida and the approach of hurricanes. And then again, the tropical season as a whole. Beryl, also a very prolific tornado producer. So not something to forget. We often look at surge and rainfall and winds associated with the eye wall. But boy, tornadoes can be fast to come about and very challenging to forecast with much lead time.
would you say that in a typical hurricane that there are tornadoes on the east side out over the ocean? I mean, or
Sure. Yeah, the
we
feeder
just don't
band.
pick them up. And
We just don't. We see them on radar as they get closer to radar. But yeah, the rain bands associated with tropical cyclones are a haven for storm rotation, just given the wind shear.
yeah. Okay, well, thanks. Hey, we got some questions coming in, and if you guys want to send in your questions or type in your questions now, we'll spend about the next 15 minutes if we can do that. Does that work for you? Trying to answer these. Oh, this is interesting. Here's a question from Chris. And he wants to know, can you comment on, and you may not know these, the 1916 storms that hit Western North Carolina compared to Helene? Similar damage with rainfall and flooding. And that we may not remember those. Maybe folks in that area do.
I don't remember that. That's why I put these talks together, so I can go back and years from now and remember them, but I can't right now.
That's fine. And Okay, here's one from William wants to know on the calendar. So the SPC calendar that you showed, can you talk about the colors and the notations? What are those enhanced and stuff?
Moderate,
Talk
moderate,
about
and
that a
high.
little bit.
Right.
Yeah.
Yeah. Yeah, so I probably could have spent a little more time on the calendar. So the Storm Prediction Center issues the convective outlooks for severe storms across the country, and they use really the basis of those forecasts is a probabilistic one, but those probabilities are converted into what we call categorical outlooks. So most days when you might have a risk for, say, a few severe storms around, the risk area might be a slight risk, which is relatively low probability that you'll be impacted directly. And then you go to used to be slight, moderate, and high. The current scale is slight, enhanced, moderate, and high. And high risk being, the most confident and potentially the most violent type of severe weather outbreak. So you don't see a lot of high risks anymore. It's either because it's the uncertainty is too great, or the atmosphere isn't quite configured to produce, very intense storms. But when they do issue high, that's a sign that you're gonna have a really active day if you happen to be in that high risk. And some parts of the country, they'll close schools and take other actions in advance of the severe weather of a high risk. Moderate, just a level below that, is also a very active day, and enhanced is a level below moderate. Meaning that either uncertainty is a little bit greater or intensity is a little less. And so that's what these different categorical descriptions for severe weather mean. And on the calendar that I showed, I was just showing the highest risk issued on the day of. So some measure of activity with respect to severe weather. Not the only measure, but I found it was a useful measure to see, well, how active was, the severe weather in April and May. And so I used the calendar approach there.
That calendar for folks out there you can go to Iowa State's website. You can actually put your location in there and find out. I've done that several times with make the calendar, see how often you've been in these different categories through the months. So it's kind of fun to play with, and you
It
can see,
is.
oh, this was a lot more. We've been in a lot more slight or moderate than we have in the past, and so
Right. Right.
it's kind of neat to see. Thanks. Okay, next one, Tom wants to know, what is confluent flow? Does warming climate he just has, does warming climate affect? I think there's maybe a correlation there.
Confluent
But
flow.
okay, a warming climate effect influence chaos is what he's saying. Okay, so he just wrote that in.
Well, so the warming climate plays a role, a lot of different potential impacts for meteorology and weather and local changes in weather too. Not sure if there's a relationship to confluent flow, and in fact, confluent flow is when you have the basically air streams sort of merging together and speeding up. Right, you're forcing that air together, and your confluent is basically coming together and speeding up, whereas difluent is spreading apart. Both can have an impact on sensible weather in different ways. I don't know of a relationship between warming and confluence or difluence. One thing in a very basic sense is that as you warm the atmosphere, you're less likely to have high speed air. In other words, the jet stream is associated with a strong contrast in air masses between the cold air to the north and the warm air to the south. And the greater that difference, the more likely you are to have a very strong jet above that difference. And so if you're warming everything up, you're probably lessening the difference in the air masses and then lessening the speed of the wind throughout the atmosphere, which should in in some sense, reduce the amount of severe weather activity, because you need that speed increase with height in order to produce organized severe thunderstorms. You need to have that shear. And so it's possible that a warming planet results in lower shear, which results in fewer environments supportive of severe weather. But at the same time, you're offsetting the potential limits in shear with abundant warmth and moisture. And so you can compensate for this weakening shear by increasing instability in terms of increased moisture and warmth. And so it may be zero sum. We may not see much of a change in the overall number of severe storms due to climate change, but we will likely see a change in where those storms occur. And so a lot of questions remain. I think the one question that's clear, though, is that we are seeing changes. It's just weather is chaotic to begin with, and very difficult to pin down. Forecasting is a challenge, but we are seeing changes in terms of the frequency of some extreme precipitation events. Severe weather events are a little bit harder to pin down with respect to the trend related to climate change.
Well, thanks, Greg. We really appreciate it. And I think that's it for questions today. So again, thank you folks for putting those in there. And Greg, we hope you'll be able to join us again next year. This is
We'll see how it goes, Henry. I appreciate the invitation.
Well, it's an open invitation, and we can talk more as time gets closer. But again, just wonderful stuff. And it's a nice history to have to go back and look at over time. So thank you.
And thanks for everything you do. A real quick shout out to all the CoCoRaHS observers. I look at the maps every day. I am now a dedicated CoCoRaHS observer now that I kind of I'm anchored here in Vermont. I'm looking out at where I have my gauge set, and I'm doing my snow liquid ratio calculations every day. And I really appreciate the dedication of other citizen scientists in doing that. It's really important information to have, and you guys do a great job consolidating it and keeping people interested. So thanks for doing that.
Well, thanks, Greg. Appreciate that plug. Well, folks, as we close out today's program, we're going to let you know that our next CoCoRaHS Weather Talk webinar will have that information on the website soon. We're still working on that one. So keep your eyes out and on the message of the day also for that. As we close out today's program, again, before I forget, when signing off today, please take the survey that will pop up on your screen. So until we meet again, we wish you a safe and healthy new year. This is Henry Regis for the rest of the CoCoRaHS team saying goodbye for now.